So, in the construction of transformer, we mean that what are different parts which are associated with the machine and what are its role. Okay, so this is all which is to be discussed in this construction of transformer as well. Okay, so the diagram is shown here. This is the two-dimensional diagram. What is visible from the outside part of the transformer is the transformer tank. Okay, so you must have seen the distribution transformers located at different parts of the city. At the first glance, we can see the transformer tank. Okay, the fat rectangular, or you can say cuboid formation, that is the transformer tank. Okay, so it is generally painted with blue or green color, or it can be painted with any other color that its heat absorbing property or capacity should be less and heat radiating or reflecting property should be more. Okay, the transformer can be in loaded condition or no load condition. Okay, so whenever there is a transformer in loaded condition, it means that the secondaries are connected to the load, and when the secondaries are connected to the load, it means that the current will be drawn from the primary side to the secondary side, and whenever there is the flow of current, the heat is produced in the form of loss, or you can say I square RT loss. Okay, so it is necessary, especially in the summer seasons in India, that the heat produced by the transformer should be within the permissible limits. If we are using such color which absorb more heat, so it is harmful, is its transformer core, which is shown here in a rectangular form is shown, but otherwise it is a shape of cuboid, you can say. Core should have the high permeability. So iron and its parts or alloys which obeys this property is accepted as a material for transformer core. Okay, it can be ferromagnetic material, it can be permanent magnet material. Okay, for example, Alcomex, Alnico. Why it is necessary? It is necessary so that the mmf produced is sufficient and the flux follows the mean path in the transformer core and leakage flux is minimum. Okay, and this core is not a single body, it is made up of thin laminated sheets. Lamination is done so that there is no eddy current losses, and these are thin of the order of millimeters, 3 mm, 0.3 mm, and so on, and then they are bolted. Okay, they are bolted so that there is no air gap between them, and when there is no air gap, then it will perform better. It will have the better magnetic properties. Okay. And again, these laminations, since the strips which are used to make these iron cores are of different shapes. So what are the popular shapes which are available to make the transformer cores? These are L, I, U, T, E. Okay, so these are the 5 shapes which are available, and these are arranged to give this square type of shape. Adjacent to these transformer core, this transformer core is generally placed in the bottom of the transformer. It is not hanging in the transformer tank, it is placed at the bottom. Okay, because it is having some weight, so it is not possible to hang them. So windings are wounded on the limbs of the core. Okay, so what are these limbs? Limbs, as you know, it is a biological name. So by limbs, which we mean that the part of the body which helps in standing, running, walking, etc. These vertical structures are the limbs. Okay, so mainly there are two type of transformers based on the construction of the core. It is core type transformer and shell type transformer, and this core is wounded from both limbs as shown by the windings. Okay, so this can be low voltage winding and high voltage winding. Okay, for example, if it is a step up transformer, then low voltage winding will be in the primary side and high voltage winding will be in the secondary side. Okay, and vice versa for the step down transformer. And these windings are generally made up of copper because it is highly conducting material, and these are taken out from the transformer tank through the bushings as shown in the top of the transformer. So then these bushings are connected to low voltage winding or high voltage winding as required. Okay, of chocolate colored shape. Okay, so at the top of them, these bushings are the its terminals through which the wires are inserted. Okay, for the transformers in which the current carrying capacity is more, we use copper conductors, and the transformers which is having less rating, or you can say 33 kV transformers, distribution transformers, we can use aluminum winding as a conductor as well. Okay, so these are aluminum windings are of different different radius, and they are varnished again to reduce the eddy current losses. Okay, okay, so what is the purpose of these wheels? These wheels run on the rails. Since the transformer itself is very heavy, and if it is filled with transformer oil, it is again adding a lot of weight to it, so it is different. It is difficult to uh, move these transformer. Okay, so the manufacturing industries, what do they have? They have tracks similar to railway tracks. It is identical to railway tracks, you can say. So these transformers are set on those tracks, and then these are moved from one place to other within the factory. Okay, then after its assembly is over, transfer assembly is over, then it is loaded to the trucks, and again at the time of loading, these wheels are very much helpful. Okay, at the bottom right you can again see this drain wall. So what is the purpose of this drain wall? As and when this transformer oil is degraded, it is not fit for use, so it is changed. So to change the old transformer oil is removed with the help of this drain wall, and new or the fresh transformer oil is inserted from the top of the transformer tank adjacent to the bushings. Okay, what is the what are the properties of the transformer oil? What is the role of the transformer oil, and what is the capacity of the transformer oil, and how is the movement of the transformer oil is governed? Now we will learn all these things. So first of all, the role of the transformer oil. So transformer oil is having two roles. Okay, so transformer oil should be filled filled up to its maximum. It should not be half filled. Okay, so the transformer oil should be covered each and every part within the transformer tank. Okay, cooling, sorry. So whenever there is no load condition of the transformer, then current is not flowing, but primary current or the exciting current may be flowing, which is although of very less magnitude. But even if the weather conditions are hot and humid, then the temperature within the transformer tank is increased. So to counter the temperature rise within the transformer tank, the transformer oil does the cooling effect. It has the cooling effect on the transformer. Okay, so it is touching different parts within the transformer tank, and whatever part it is touching, it is cooling them, whether it is transformer winding, whether it is core, its bushings, windings, etc., whatever it may be. Okay, and the when this transformer is subjected to loaded condition. Okay, especially full load condition. So when it is on full load, maximum current will be drawn, and when maximum current is drawn, maximum I square RT heating will be there. The heat is produced due to the passage of current, and transformer core is placed at the bottom of the transformer tank. So heat is produced there. Okay, so the transformer oil which is surrounding the transformer core gets heated. Cooling is done by obeying the Newton's law of cooling. So the transformer oil is cool, and due to the passage of current, heat is produced. So the transformer oil will also get heated up. Okay, and liquid, any liquid, when it gets heated up, it becomes light, and when it's become light, it rises, and the cool transformer oil which is on the top of the top portion of the transformer tank, being heavy, it comes down. Okay, so this process is known as convection. To enhance the cooling within the transformer tank, these fins and channels are provided. So it provides the additional passage for transformer oil to move from down to up. Okay, so we are giving extra area, extra path, so cooling will be enhanced. Okay, so this is the one role of the transformer oil. Other role is its insulation. Insulator is the element which does not allow the passage of current within it. Insulation provides the stoppage of flow of current. Okay, so where current is flowing in the winding, and uh, these windings, if they are having loose connections, they can touch the transformer tank, and when they touch the transformer tank, there will be leakage current. Okay, so transformer oil prevents the flow of current from transformer core to transformer tank. Okay, also, since these windings are attached or connected to the core, so it can also, if the large current is there, it can also damage the transformer core. Okay, so these oils are also connecting these cores and windings, so fault current or uninterrupted supply of current, large current, is prevented. Okay, so to prevent the leakage flux, these windings are alternatively connected: low voltage, high voltage, low voltage, high voltage. This is called interleaving. So it prevents the leakage flux and the leakage reactance. So In general diagram, we can represent the winding in the transformer core as shown, but in actual practice, these windings are alternatively placed. Okay, so these are two roles of the transformer oil. So what should be its properties? First of all, it should have the good heat radiating properties so that it's cooling. It can stimulate the cooling. Second is its viscosity. It should be less viscous in nature. Okay. If it is less viscous in nature, then the movement of the oil will be more. More is the movement of the oil, more will be the cooling. Okay. It should not form the poisonous mixture on oxidation. Transformer oil generally leaks from its connecting parts. Okay, so it should not form the poisonous mixture in the atmosphere so that it is harmful. And its flashover point should be high. It should not catch fire easily. Okay. Next, it should be non-hygroscopic in nature. Okay, it should not catch the moisture easily. Okay, although it is uh, made up of saturated hydrocarbons, resins, polymers, isomers, etc. Unsaturated hydrocarbons should not be present here. Okay, so these are its main properties. So we have also mentioned here that the transformer tank should be filled with transformer oil to the fullest. Okay, so to maintain the full capacity or the 100% capacity of the transformer oil, the half filled cylindrical body is connected in a tapered manner using pipe, and this is called conservator as shown. Okay, so in the winters the oil contracts. So when oil is contracting, then the extra oil is supplied from the conservator to the transformer tank. Okay, and during the summer and full load condition, the due to rise in temperature, the transformer oil expands. So when it is expanding, again the extra oil is transferred from the transformer tank to the conservator. Okay, so conservator is also having the oil indicator level, which shows how much oil is filled in the conservator. Okay, so temperature control indicator is also there, and in between the conservator and the transformer tank is the Buchholz relay. Okay, so what is the relay? Relay is the uh, electric device which identifies the fault and tries to prevent it in a best possible manner. So here this Buchholz relay, it identifies the internal faults of the transformer. Okay, so whenever there is internal fault, what is fault? Fault is nothing but the uncontrolled flow of current. The windings are there is a desired path of the current, but if that path is not followed and the magnitude is more, then it is called fault or short circuit. So whenever there is a fault or short circuit, large amount of current is flowing. Okay, so when large current is flowing, more is the heating, or I square RT heating is more. When more is the heating, then more will be the temperature rise. So when these temperature rises, then the gas bubbles are produced in the transformer oil, as in the case of boiling of water. Okay, the gas bubbles are produced, same is the case here. So this Buchholz relay is having a transparent glass window. Okay, and it is connected to the transformer tank. So this is gas actuated relay. So when the bubbles which are produced are more, and it passes from transformer tank to conservator, we can identify that the fault is more. But if the less amount of bubbles are produced, then we can say that the low fault is there. Okay, this is the way of detecting the magnitude of the fault. How this Buchholz relay identify the type of fault? So type of fault is identified in a way that whenever there is a burning or combustion of any parts, then the gases are produced. Okay, so different colored gases are produced on the combustion of different. So if there is a line to line fault or line to ground fault, windings are short circuited in between, then the copper is burning. So when the copper is burning, so the gas produced can be the cuprous oxide or cupric oxide. Similarly, if the short circuit fault is at the transformer core, which is ferrous in nature, so the ferrous oxide, iron oxide is produced. So it is having different color. Okay, some similarly some bolts are there. So whenever the bolt insulation failure is there, again some iron parts are burning. So those gases are of different colors, which can be viewed from the transparent window of the Buchholz relay, and hence the location of the fault can be identified. So whenever the faults are more, the carbon black is produced, sludging is produced, and also sludging is due to the aging of the transformer. So its insulating properties and the cooling properties reduces. So when we see that its cooling properties and insulating properties are reduced drastically, we can replace the transformer oil. Okay. Next conservator is connected to this silica gel and breather. So what does breather do? Breather allows the air to pass through it, but it is connected, it has to pass through the silica gel. So what is the role of the silica gel? Silica gel role is to absorb the moisture. So silica gel stones are placed in this silica gel container. So these are blue colored stones. Okay. So as they absorb the moisture, their color start to change. The blue color, dark blue color changes to light blue color, then it changes to dark pink, then light pink, then off-white color. Okay, so when its color changes to off-white color or light pink color, then the stones of these silica gels are taken out from these containers and in the sunlight. So when these stones are again placed in the sunlight, the color of these stones change from light pink to dark pink to light blue, and blue. Okay. So then we can again place these stones back to the container. Also in between the blue to pink, some chocolate, light chocolate color, brown color uh, is also adopted by these stones. So this process continues for many terms, but a stage is reached when the color of these stones do not change. So when the color of these stones do not change, we can realize that the time has reached to replace these silica gel stones with the new ones and not the reused ones. Okay. So this is the magnetic core, and vertical parts are limbs or legs, and the horizontal parts are called yokes. So it is made up of CRGO, cold rolled grain oriented steels. Okay. And apart from what we have mentioned, so these laminations can be of 0.3 mm to 5 mm. It increase the electrical resistance between the laminations. Okay, so the eddy current can be reduced. So these are the shapes of the laminations, which can LIUTE, which can be aligned to form the core. Staggering means the air gaps between the joints, it should be avoided. Okay, so these are tightly bolted and varnished and vacuum impregnated. This is the interleaving, in which the core is alternatively wind by low voltage winding and the high voltage winding. It reduces the leakage reactance. Insulation are classified in the form of YAEB, FHC, based on different temperature sustaining capacities. So these are the functions and the properties of the transformer oil. Conservator is semi-filled oil tank. I have mentioned you Buchholz relay. Okay, Buchholz relay can, when there is more flow of the oil, it it generates the alarm circuit, so that the in the vicinity, if someone is there, he can identify. But if the fault is more, then the circuit breaker is attached, and that circuit breaker can also uh, disconnect the circuit, so that the any eventuality is voiced. So this is breather, which is having two components of transformer oil, which I have mentioned. So this is transformer tank. So transformer tank are generally made up of welded sheet steels. Okay. And large transformer tanks are made from the plain boiler plates. Okay. And it should have the eye bolts, again used for picking up, and it can have the pockets, rollers. These are wheels which I have talked. Bushings I have informed you. So it is chocolate color porcelain cylinders, and terminals are connected to it. Okay, so